Hello, can you hear me?
Yes, sir.
Okay, so we'll do physics today. We have finished roughly the thermodynamics revision. We'll start off with another topic that is quite important. Many questions will come from it. So that is your SHM, waves, and sound. You have
Okay.
not done the revision for these right now, right?
No, sir.
Okay, so we will do some questions on it, and through that we'll revise the topics. You are working on electromagnetism and mechanics, right?
Yes, sir. I did modern physics also.
Hmm. Okay, so we'll start off with questions on SHM waves and sound. So first one is JEE 2024. Uh, a block of mass, a block of mass 5 kg moves along x-axis subject to a force of F is equal to minus 20x plus 10. Okay, 1 second. Is minus of 20x plus 10 inside a bracket, Newton. uh, where x is in meters. At t is equal to 0, it is at rest at the position x is equal to 1. You have to find the position and momentum of the block at t is equal to pi by 4 seconds. Try it out.
Yes, sir.
You have to use your knowledge of SHM to try to figure it out.
Right.
Don't try to do it by some brute force method.
Okay.
So in SHM, what do you have? F is equal to minus kx, right?
Right.
If it was like this, you know x is equal to a sine omega t plus phi, right?
Yes, sir. Right.
That is the solution of the differential equation that will come from here, right?
Hmm.
Great. We can find omega also and so on, root k by m and all, right?
Right.
So we are going to use that information. We are not going to do everything again and again, right? So here the force equation is given, but we don't have it like F is equal to minus kx. We have something like minus kx minus c, right?
Right.
But that is not a problem. We
Yeah.
will we'll do 20 common.
Yes, sir.
So we'll say minus 20 common x minus half, right?
Yeah.
Wait 1 second, it is x plus half.
Yes, sir.
Right. So this will come, and now this this thing is our capital X,
Hmm. Right.
correct?
Yes, sir.
So capital X would be a sine omega t plus phi, right?
Yes, sir.
And now we know that it is SHM. We can find K also easily, no issues in that because mass is given, right?
Hmm.
Omega we can basically find as root K by M, right? So 20 by 5 4, so omega is 2.
Two.
Now once you know omega, you know time period, right? 2
Yes.
pi over 2.
Hmm.
So it is pi. Pi is the time period, and this time is 1/4 of a time period, right?
Yes, sir.
Also in the beginning, where is it? It is at x is equal to 1, right?
Hmm.
So capital X would be what? 3 by 2.
Yes, sir.
You should realize that uh, in the beginning, what is x? That tells us a and phi, no?
Yes, sir.
Because the velocity is 0 and x is given at the beginning.
Hmm.
So basically, capital A and capital phi can be found from the data here.
Right.
That velocity is 0 and so on, right?
Yes, sir.
And then obviously it is at rest and it was a simple SHM, so it must have been at an extreme position.
Yes, sir.
And 1/4 of a time period means later it will be at equilibrium, right?
Right. Yeah.
This is SHM. Extreme position, if you start, this is 1/4, right?
1/4.
This is half, then you come back, it is totally T.
Hmm.
So you are at equilibrium position, which will be when capital X is 0, which is at minus half, right?
Yes, sir.
Small x is minus half. And now velocity will be maximum at equilibrium, right?
Yes, sir.
So velocity will be a omega basically. Once you find out a, you will get the a omega also.
Yes, sir.
Do you understand what I'm saying?
Yes, sir.
So that is how you use SHM information. Otherwise, you don't have time to do the whole solution again. You have to rewrite it in the form of SHM and then do it.
Yes, sir.
Is it clear?
Hmm.
Okay. Question number 2. The figure is drawn. There are 2 point objects. Masses are given at the ends of a rigid massless rod of 10 centimeter. This is a rod of 10 centimeter. The system is suspended vertically from a rigid ceiling using a thin wire. This is a thin wire and attached to its center of mass of the rod, so midpoint of the rod. This is a torsional pendulum. the resulting torsional pendulum undergoes small oscillation, undergoes small oscillations. The torsional constant K is equal to 1.2 into 10 power minus 8 Newton meter by radian. The angular frequency of the oscillation, omega of the oscillation, is n into 10 power minus 3 radian per second. You have to find n. It's a torsional pendulum. You just have to find n, or frequency of oscillations. Okay, so I made a mistake in saying it. So what it was suspended vertically, it was suspended vertically such that this point is attached, the wire is attached to the center of mass of the rod.
Okay.
So it will not be midpoint then. Do you know how this torsion and all works? Torsion, what is torsion and all?
Um,
The basic idea of a torsional pendulum is that whenever you rotate a wire, then it will try to untwist itself, right?
right.
If you twist a wire by some angle theta, there is a tendency for the wire to untwist itself.
Yes, sir.
So if I have rotated, let's say this was attached to a circle and there is a radius here. Earlier it was like this, but I rotated it and twisted it by this much. If I rotated it by theta, the torque in the wire, which is known as the torsion that is generated to untwist it back, will be minus k theta. That's the rule for a torsional pendulum. This k they have given you, right?
Yes, sir.
Notice that it's a unit of torque by angle. See,
Right.
Newton into meter is torque, right?
Yes, sir.
So basically the torque generated, which is like a restoring torque, is minus k theta. So that automatically, if you attach a ball or something mass m to it, then it will try to spin back now, right?
Right.
So that is your restoring torque. In this setting, there is a rod attached with center of mass here, and that will experience that torque, right?
Right.
Do you understand what I'm saying?
Yes, sir.
Because you're twisting the wire wants to untwist. So you'll basically you're saying that you are giving a torque like this to the rod,
Yes, sir.
because of which it is spinning. So
Right.
if you twisted it by theta angle, the torque is minus k theta, restoring torque. So you should write minus k theta is equal to I alpha, right?
Hmm.
Here the I alpha is for the big rod here.
Yes, sir.
That will tell us how the big rod is rotating.
Right.
But the main part of the problem is calculating the I, right?
Hmm.
So how will you calculate that? Because if I know the I can write alpha is minus k by I theta. And this becomes our omega square, right?
Yeah. Yes, sir. Right.
So basically your omega is simply root over k by I, right?
Right.
That's your SHM using torsion. So all we have to do is find the I and then we'll get the answer.
Yes, sir. So 10.
N is equal to 10.
Yes, sir.
Basically, you just remember that this is center of mass, so this distance will be less than this distance.
Yes, sir.
And you do I as m1 r1 square plus m2 r2 square. And after that, you put k by I and you'll get the answer.
Right.
So you need to, like, if you don't know about torsion and all, just revise your SHM and oscillations theory once, right?
Yes, sir.
Question 3 is on a frictionless horizontal plane, a bob of mass m is equal to zero point 0.1 kg is attached to a spring of natural length L naught is equal to zero point 0.1 meter. The spring constant A1 is 0.009 Newton per meter when the spring constant K1 is this when the length of the spring L is greater than L naught and is K2 is equal to 0.016 Newton per meter when L is less than L naught. Initially, Bob is released from L is equal to 0.15 meter. Assume that Hooke's law remains valid throughout the motion. Throughout the motion, if the time period of the full oscillation is n pi seconds, you have to find n. So the question is a question where the spring constant changes in a certain way, right?
Yes, sir.
And you have released the bob from an extended state and you have to find the total time period.
Hmm.
Okay, try it out. Are you getting something?
Uh, Sir, it's not an integral
It will
value.
not be an integer. It is closest to an integer.
Sir, 6?
Uh, your answer should be 5.83.
Yeah, right.
It will not be an integer. Basically, in this portion, the spring constant is different, right?
Yes, sir.
When L is greater than L naught, and after that it gets compressed, that time spring constant is different.
Yes, sir.
But each of the portions is basically a half of the
Half
period,
of.
right?
Yes, sir.
So you also do pi root over m by k1, right?
Yes, sir.
And similarly pi root over m by k2.
Hmm.
So these will be the times that will be added and you will get 5.83, right?
Yes, sir.
Okay, fine. Then the next one is a particle of mass 1 kg is subjected to a force F is equal to minus k xi plus yj, where k is equal to 1 at t is equal to 0. Particle's position vector is 1 by root 2 I cap plus 1 root 2 j cap, and velocity vector is minus root 2 I cap plus root 2 j cap plus 2 by pi k cap. Okay. Let Vx and Vy be the x and y components of velocity. Ignore gravity when z is equal to 0.5. What is the value of xvy minus yvx? That is what they're asking. What is the value of this? They have given position and velocity at t is equal to 0, and they have given the force and mass and k value also.
Hmm.
So one thing to remember is principle of superposition. That is how two SHMs can be combined, right?
Right.
Whenever a particle undergoes multiple forces and all, if the forces are creating SHMs in some direction, the resultant displacement is the sum of the
Some the
displacements due to the individual SHMs and so on, right?
yes, sir.
So that principle is what will be useful here because there is force in both X and Y, right?
Hmm.
So technically you should realize that it is SHM in X direction and also in Y direction.
Right.
They have given you initial position and velocity at t is equal to 0 and they are asking you for this stuff at a later moment, right?
Right.
So don't get overawed by the calculations. It is actually simple only, it's just a little bit of calculation is required. Because f is minus kxi, the x will be a sine omega t plus phi,
Yes, sir.
right? You can
Hmm.
call it ax and all,
Yeah.
right? And if x is this, vx would be ax omega cos omega t plus phi.
Right.
At t is equal to 0, if you put the position is 1 by root 2 I cap, velocity is this, right?
Hmm.
So 1 by root 2 is equal to ax sine phi, and minus root 2 is equal to ax omega cos phi, right?
Right.
Omega can be calculated because k by m is 1, omega is 1, right?
Yes, sir.
So k by m is 1, yeah, omega is 1. So based on this, we can square and add, we'll get ax square, right?
Yes, sir. Right.
We'll get ax square is equal to half plus 2. So 3 by 2. Ax is 3 over root 2, right? Correct?
Yes. Sir, whole under root, right?
Oh, right. 5 over root 2, right?
Yes. 500.
Right. 5 by 2. So,
Will
I'm
be
making a
whole
mistake.
under root.
It will be full under root 5 by 2, right?
Yes, sir.
So that is your ax. So then you get sine phi and cos phi, right?
Hmm.
So you will get basically values of sine phi. Sine phi is coming out to be 1 by root 5,
Right.
right? Correct?
Yes, sir.
Now we know a also, we know phi also. So we can put x here, we can put vx expression also, right?
Hmm.
Correct, no?
Yes, sir.
All we need to figure out is the time. Similarly, you can do y stuff also.
Yeah.
Based on the data, it will be the exact same process, right?
Yes, sir.
Just with different values, right?
Yeah.
And when will z be zero point 0.5? Notice that there is no force in z, right?
Yes, sir.
So this is a constant velocity,
Yeah.
and the position, starting position was 0 k cap, right?
Hmm.
So the time taken to reach this zero point 0.5 will be zero point 0.5 divided by 2 over pi, right?
Yes, sir.
So it is pi by 4 is the time, right? At pi by 4 time, find out Vx, find out Vy, and put it in x and y. Like basically these expressions, right?
Yes, sir.
Just try it out and see if you're getting some nice answer.
Yes, sir. Sir, I have a doubt.
Mhm.
What did you do when you squared AX?
I have ax sine phi and ax cos phi, so square and add, right? To
Okay.
eliminate phi.
Right, right. Yes, sir.
And if you want to do tan phi, you can divide to get tan phi to get phi.
Yes, sir.
Squaring and adding removes the phi variable and gets us ax.
Right.
If you do the calculations correctly in the previous one, the answer should come as 3 or something.
Okay. Making some mistake.
1 second. See, so in the previous one, we had x was, we got ax as root over 5 by 2, and we got tan phi as minus half, right?
Hmm.
By dividing sin phi and cos phi.
That's right. Yes, sir.
So, and your x came as ax sine omega t plus phi, and your vx came as ax omega, but omega is 1.
Yes, sir.
So, it's like this, right?
Hmm.
Similarly, it's an SHM in y also because the force was minus ky, right?
Yes, sir.
So y will be similarly ay sine omega t plus phi, but this phi is different phi. So we can write it as phi 1, right?
Yes, sir.
And vy would be ay, w is 1, so that it doesn't matter.
Hmm.
So cos omega t plus phi 1. And now from the data at t is equal to 0, position was root 2, right?
Root 2.
So ay sine phi 1, and velocity was also root 2.
Root 2.
So ay cos phi 1, right?
Yes, sir.
So you are getting clearly tan phi 1 is 1.
Hmm.
When you divide, you are getting tan phi 1 is 1. So phi 1 is pi by 4, right?
Yes, sir.
And then you put here 1 by root 2. Ay is coming as 2, right?
Yes, sir.
Ay is 2. Phi 1 is pi by 4, right?
Hmm.
Now we know the stuff about this. All we need to find out is that expression, which was x vy minus y vx, right?
Right.
X vy. So x stuff multiplied by vy stuff. So it will be ax ay sine into cos, right? Sine omega t plus phi cos omega t plus phi 1, right?
One. Yes, sir.
Minus it would be ax
Both the.
vx into y, right?
Yes, sir.
Ax ay cos omega t plus phi
And
into
sine.
sine omega t plus phi 1.
Yes, sir.
Ax ay can be taken as common, and you can say it is ax ay, and notice this is sin c
Sine of.
minus d, right?
Yes, sir.
Sine of this minus this, right?
Hmm.
So it is sine phi minus phi 1, right?
Yes, sir.
Ax ay product, if you see, it is root 10,
Yes, sir.
correct?
Hmm.
So root 10 into sine of this thing where tan phi is given, right? And we knew sine phi was 1 by root 5 and stuff, right?
Yeah.
Do you understand what I'm saying?
Yes, sir.
So cos phi would be minus 2 by root 5,
Hmm.
correct?
Yes, sir.
So it's just about calculating this, right? So
Right.
1 by root 5 cos phi 1 is 1 by root 2, right? Minus 2 by root 5 into 1 by root 2, right?
Hmm.
So it will be plus 2 plus 1, 3 by root 10, right? So 3.
Yes, sir.
The time actually was pi by 4, but time didn't even come into the picture, right?
Right. Yeah.
We didn't even need to find time because actually it turned out that the expression is independent of time, right?
Yes,
It
sir.
only depended on ax, ay, and the sign of phi minus phi 1.
Yes, sir.
So that is the solution. Ultimately, the problem is not difficult. It's just that you have to know your SHM equations and know how to handle them and not be scared of them. And know that if the forces are in both the directions, there will be SHM in both the directions.
Yes, sir.
X and Y, there will be separate type of motion, right?
Hmm.
Is it clear?
Yes, sir.
Okay, you can try this problem for homework. Just write it down right now. Uh, if this is equal to this at t is equal to pi for the first time, the value of t is not equal to pi, t is equal to a variable tau. We have to find the variable value of this tau variable in seconds. Basically, there are two vectors. B is looking like a combination of two SHMs, right?
Right.
This vector equation is true for the first time here.
Hmm.
Okay, so try this one out. Actually, maybe try it right now only. It's not so difficult.
Sir, 2.
That's correct. You just have to simplify the vectors first.
Yes, sir.
You do a plus b, you'll get a plus a cos omega ti
Hmm.
plus
Yes,
sine
yes,
omega
sir.
tj. And the mod of this is not very difficult to find.
Yes, sir.
If you do the mods properly right now, a plus b and a minus b, automatically you'll get a trigonometric equation, right?
Hmm.
You should get something like tan of omega t by 2 is equal to 1 by root 3. Correct?
Hmm. Right.
And after that, you just find omega t. The first time is this when this happens, right?
Yes, sir.
Okay, so basically, we will focus on this topic, SHM, waves, and sound for the next couple of classes in physics, and try to make sure that if there is any easy question on this, you need to be able to do it. So, the questions on this are mostly theoretical. As long as you know your theory, it is unlikely that there will be a very tough question here.
Right.
So you need to know your theory really well. So do a little bit of a revision for these chapters. Use
Okay.
HCV, use your module. Just do your revision for these three chapters. Okay.
Yes, sir.
We'll work on the advanced problems for all of them in the next couple of classes as well.
Hmm.
Okay, fine. That's all
Thank
for
you.
now then. Bye.